So dear students, welcome to the unit number 3rd. In this unit number 3rd, you are going to get introduced with different heterocyclic compounds. First of all, we will study how to do the nomenclature of heterocyclic compounds. You will study basic heterocyclic compounds, their common names, their naming system, hence Widman nomenclature, and you will study different method of preparation and chemical reactivities of basic 5-membered heterocyclic compounds like thiophene, furan and pyrrole. Moreover, you will study their aromatic behavior and their order of their aromatic behavior according to their chemical properties. So without much delay, let us enter into our unit number 3rd. Now dear students, we will start our unit number 3, which is nomenclature of heterocyclic compounds. So in this unit we will study what heterocyclic compounds are, how many different kinds of heterocyclic compounds are there, and we will also study their nomenclature, and we will study a few heterocyclic compound and their aromatic behavior. Now let us start our topic with the first notion, with the first definition of heterocyclic compounds. So heterocyclic compounds are those in which one or more carbon atoms of a carbocyclic ring are replaced by or is replaced by heteroatoms like nitrogen, oxygen, sulfur, etc. So heterocyclic compounds are those in which one or more carbon atoms of a carbocyclic ring is replaced by the heteroatom. Okay, so what is a carbocyclic ring? A carbocyclic ring is that which is having only carbon atoms as the members of the ring. So here is an example of a carbocyclic compound, CH2, CH2, CH2. This is cyclopropane. So in cyclopropane, when we replace one atom, say this carbon, with oxygen, we get a heterocyclic compound. In the same way, let's say we are having a benzene ring, and in this benzene ring we replace one carbon of the benzene ring and we replace it by a nitrogen atom. So when we replace a carbon ring by a nitrogen, we replace a carbon in the ring by a nitrogen atom, we get pyridine, which is again a heterocyclic compound. In the same way, let's say we are having a cyclopentane and we replace one carbon atom with one nitrogen atom, so we get pyrrole. Maybe if we can do, we can also replace this pyrrole, okay, we can also replace the third carbon of this pyrrole ring with again a nitrogen atom, and we get imidazole. So these are compounds which I have just now shown you. They are all heterocyclic compounds because they are cyclic and contains a heteroatom, an atom other than carbon in the ring. Now a very interesting thing is how does nomenclature of heterocyclic follows. What is the nomenclature system of heterocyclic compound? How do we give them names? So, the nomenclature of the heterocyclic compounds mainly follows three categories. Number one is the Hans-Widman nomenclature. The Hans-Widman nomenclature. The second way of doing nomenclature is the common name method. And the third way of doing is the replacement nomenclature. The replacement nomenclature. So let's start understanding the nomenclature of heterocyclic compounds by our first category, which is the Hans-Widman nomenclature. Now, according to Hans-Widman nomenclature, you have to see that the nomenclature, the naming system depends on two things. Number one is the ring size, means how many atoms are there present in the ring. Okay, and the type of the heteroatom, which is there. And the third thing is the nature of the ring. Nature of the ring means whether our ring is saturated or unsaturated. Now see that we are having a heterocyclic compound where we are having n number of carbon atoms. Okay, in the heterocyclic compound, total n number of atoms, and this is the heteroatom which is connected here. So we have to see these things, these three factors, and we have to do the nomenclature accordingly. So for that there is a table, or you can say a guideline. Number one, when we have to see the type of heteroatom, the first factor which we say that the type of atom decides what name should be given. So type of heteroatom. Okay, so type of heteroatom says that if the heteroatom is oxygen, then we have to use the word oxa. If it is nitrogen, we have to use aza, and if there is sulfur, we have to use thia, and if there is phosphorus, we have to use phospha. Okay, the name is indicated by a prefix. It usually comes in the name as prefix. Prefix means something, the name which is coming before. Okay, now talking about the second factor, ring size. Ring size, which is n. Now say if you are having a ring size can vary up to 3, 4, 5, 6, 7, 8, 9 and 10 members. So ring size can vary from 3 to 10. We can have 3 to 10 members. So if ring size has these numbers, then we have to use the suffix means that will come later on as IR for 3, for 4 it is ET, for 5 it is OL, for 6 it is IN, for 7 it is EP, 8 is OC, 9 is ON and 10 is EC. like this. Okay. The third thing is whether ring is saturated or unsaturated. The third factor that I have told you is whether the ring is saturated or unsaturated. So for that there is again a table. We have to follow this table. The first column of the table denotes the ring size. The second column tells us about saturated or unsaturated condition, unsaturated state. And the third is if it is saturated and having nitrogen. Okay. Now let's say if the ring size is 3 and it is saturated, and you know that for 3 we have to use the suffix IR. They will use IR, but if it is saturated you have to use the suffix ane. If it is unsaturated then IR and you have to use INE. But if it is saturated but with nitrogen, you have to use IR and IDINE, iridium. So now you understand that IR means that IR indicates the ring size, that is of 3 atoms. If it is saturated we will use the word ane, if it is unsaturated we will use the word ene, and if it is saturated but with nitrogen you have to use word iridium. See, this saturated thing is only applied for oxygen, sulfur and phosphorus. Remember this one. For nitrogen we have, and if it is saturated we have to apply a different nomenclature. But if it is unsaturated, whether it is oxygen, sulfur, phosphorus, nitrogen, you have to use the word ene. Now coming to the ring size, which is of 4 atom, you know that for 4 we have to use at, for 5 you have to use all, for 6 you have to use in, for 7 you have to use ap, okay, for 8 you have to use oc, for 9 you have to use on, okay, and for 10 you have to use ac. And for everything, if it is saturated with oxygen, sulfur, phosphorus, you have to use the word ane at the end. Eat ane, okay, eat ane, then olane, in ane, ap ane, oc ane, on ane, ac ane. So for saturated and having oxygen, sulfur, phosphorus, not nitrogen, you just have to remember the number, the prefix that the suffix that we use for the number plus ane. Again, if it is unsaturated, then again you have to repeat the same name with the number. It starts with the same number: at, all, in, ap, oc, on and ac. And now you have to add irene for the 3-membered ring. But for 4-membered ring, if it is unsaturated, you have to apply eat, e. For 4, 5 or 6-membered ring, you have to use the word e. You have to use the letter e at the end, okay. And for rest of the 7, 8, 9, 10, you again have to use in. So this is somewhat different, and you must know how to, you must remember what conditions are applied. So it is easy that if the molecule is saturated, then you just have to use the word ane at the end plus the number that it indicates the number of members in the ring. For unsaturated, numbers are same, but at the end you have to use ene for 3 atoms. 4, 5, 6, for 4, 5, 6 members you have to use E at the end. For 7, 8, 9 and 10 you have to use INE at the end. Now what happens when we have nitrogen and it is saturated? If there is a 4-membered ring, then we have to use at, because at is used for 4-membered, and you have to use IDINE. For 5 members you have to use ol and have to name IDINE. So this thing, if it is saturated with nitrogen, then this thing applies for only 3, 4, 5 ring. So the saturated with nitrogen applies only after 5, that is for 6, 7, 8, 9. So you can also apply for nitrogen as well, but only after 6 members, from the 6 members. Okay, so these are the rules that you have to use, and everything now that arises is learned can only be done through the practice. So let us do some practice and see what are the names. Okay, now you see, let's see what should be the name of this heterocyclic compound. Now as you have seen that name of heteroatom is given first, so the name, you see that for oxygen the word oxa is used, so we'll use oxa. Then it is a saturated oxygen 3-membered ring, and then we have to use the word irene. So then you have to use the word irene. So when you will write the name of it, A will become obsolete, it will become silent, and we will get the word oxirane. Okay, now let us see, we are having oxygen 3-membered, having oxygen but a double bond, it is unsaturated. So for oxygen you will use oxa, but because it is unsaturated you will use irene, and hence A will be removed and the name will be oxirene. Okay, in the same way, if we are having nitrogen, but with, say, we are having nitrogen but as a 4-membered but saturated ring. Now how will we name it? For nitrogen we have to apply as a, but 4-membered saturated ring, 4-membered saturated with nitrogen, we have to apply etidine. So the name A will be dropped and the name will be azitidine. So dear students, I understand that initially it would be difficult for you to get the name, to remember this table, but I recommend that you should keep this table handy with you while doing the nomenclature initially, and after a while when you will get practiced through this, it will be easier for you to understand and remember everything. Okay, so let us do few more examples. Let us say we are having N unsaturated with nitrogen. Now because this is unsaturated ring having nitrogen, so for the nitrogen word aza is used, and we are having a 5-membered ring and unsaturated, then we have to use the word ol from it, and A will then be removed and we will get azole. So azole is the name. Its common name is pyrrole. We will take it later on. Okay, now can you tell me what should be the name of this heterocyclic compound? Now this heterocyclic compound, due to oxygen its first word will be oxa. Then as it is 5-membered ring and saturated, so saturated 5-membered ring, for oxygen the word olane is used as suffix, so A will be dropped and the name will be oxolane. Okay. Now what about this name? Now what about this name? As because there is nitrogen, we have to use the word aza, plus it's a 6-membered ring. Okay, for 6-membered ring unsaturated we use ene, aza plus ene, hence it is known as azine. It's a very famous molecule, its common name is pyridine. So this is how we give the nomenclature. Okay. Now let us move in a bit into more complicated ones. Say for example, there is a molecule in which there is a substituent. Okay, like this. Now this is the how will you name it? Okay. Now the oxygen, the heteroatom is always given the first number, and we have to move in such a way that the substitution gets the lowest number. So obviously this would be 2. So we call it, as the name of the heterocycle is oxyrane, by hence we given nomenclature. So we say that its name is 2-propyl oxyrane. Okay. In the same way, let us say we are having 2 substituent. One is Br and other is CH3. Now how will you name it? Obviously in this way you have to move as per the priority order, as per the alphabetical order. So the N will be given the first position, bromine will be given the second, and methyl will be given third. So its name will be 2-bromo 3-methyl aziridine. Okay. Now let me give you one more example. Let's say we are having saturated thiophene, and there is bromine here adjacent to sulfur, and there is ethyl group C2H5. Now how will you name it? Okay, so how will you name it? As because you see that bromo and ethyl are at different position, now you cannot name them alphabetically. You have to name it as per the lowest locant rule, and lowest locant rule says that sulfur is 1. Then you have to move in such a way that the position, sum of the positions is minimum. So bromine will be given the second position, followed by ethyl, which will be given the fourth position. Hence its name will be 2-bromo 4-ethyl thiolane. So this is the structure. Now now let's give one more example of a larger compound. Let's say we want to give the name of this compound. Okay. So we are having this compound, and now how to give the nomenclature of this compound? Now you see that the number of members are 1, 2, 3, 4, 5, 6, 7 and 8. We are having 8 members in the ring. So aza is there due to nitrogen, and as because 8-membered ring and it is unsaturated, hence we will give the name ocene plus ocene. Hence its name will be, A will be removed the name will be azocine. Okay. Now let's see if there is partial unsaturation. Okay. Let's see if there is partial unsaturation in the molecule, then how will be given the nomenclature. So let's take an example of azapine. Let's say we have azapine. Okay. And we have NH group over here. Azapine is a 7-membered ring. So this is 1, 2, 3, 4, 5, 6, 7. A 7-membered ring having alternative double bond. Okay. Now we are having this azapine. Now this azapine is partially saturated at this position. Let's see that this azapine is saturated at this position. Okay. Here at this position. Now what will be the name given to it? So in this case we say that previously there were only 2 hydrogens at 6 and 7 position. Now we add 2 more hydrogens at this position to reduce the double bond. I have not shown any of the previous hydrogens. I am just showing those hydrogens which are new and which have been added so as to reduce the double bond. So what we'll do this, that we will give them the lowest number. So nitrogen will be given the first position, this will be given second, this third, then fourth, then fifth, then sixth, then seventh. Now we will call it as a, we'll first say the position of the saturation. It is 2, 3, means there are 2 hydrogens at 2 or 3. So we'll say 2,3 dihydro, and as because this is 7-membered ring, it is known as azapine. So this is how we do the nomenclature. So if when there is any unsaturation or when there is unsaturation absent, if it is saturated partially, then this is, we have to say, we have to give the positions where double bond is missing, and we have to say that there are 2 more extra hydrogens attached to it. Let us say now, let us give one more example of this azapine, and let us say that in azapine now the double bond lies over here. Let's say double bond is there. Now double bond is removed from this position. Now what will be the name given to it? So the name given to it will be 1, 2, 3, 4, 5, 6, 7, because if we move from this side 1, 2, 3, 4, 5, again this bond will get 4, 5 position. So you have to remember that you have to give the lowest position to the saturation part. Now as because one double bond is removed, it means there are 2 extra hydrogens. Now we will say that this compound is 4, 5 dihydroazapine. Okay. So this is the way how we say that double bond is formed. Okay, now let me give you one more example. Let me give you one more example. Okay, so now you see that the hydrogens, the double bond is somewhere shifted, and the hydrogens, new hydrogens are on this position and this position. Now how will you do the nomenclature in this case? Now obviously you have to move from the nitrogen, and you have to move on this side where the first hydrogen, extra hydrogen which has been attached to it, is there. So this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. You cannot move from this side, because while moving from this side, the first hydrogen will come at 5th position. While moving from this side, the first hydrogen will come at 2nd position. So that is why its name will be 2,5 dihydroazepine. So this is how we give the name of partial unsaturation. Now let us say if we have this partial unsaturation along with a substitution. Okay. Now let's say this is the molecule, and we are having one methyl group at this position and one ethyl group C2H5 at this position. Now you see that it was previously, without substitution, it was previously 4,5 dihydroazepine. So first of all, consider that this is 4,5 dihydroazepine. Now what should be the nomenclature? So this one is ethyl group. It is always given the first position, so at the first position this is ethyl. Now how will you move? Either you can move from this side or you can move from this side. Now because you are two having option. Now if you move from this side, you will get 1, 2, 3, 4. This would be the 4th position. Now if you move from this side, you will have 1, 2, 3, 4. So from either side, when you are moving, you are getting to the 4th position, right? Now the rule says that you have to give priority, numbering priority, to the saturated atom. Means you don't have to look at the substituent, you have to look where the nearest saturated atom is present. So saturated atom must be given priority. So from this side you are also getting saturated atom at 4th, and from this side you are also getting saturated at 4th. But you see that among this, which one will given priority? The one which is having a substituent on it. Then first of all, saturated must be given priority, then the substituent must be given priority. So in that case you have to move from this side. So this side, moving from this side is correct, moving from this side is wrong. So the name of this structure will be 1-ethyl 4-methyl 4,5 dihydroazepine. Okay, let us take one more example, final example. Let's say we are having only one double bond over here and C2H5 attached to the nitrogen and CH3 attached to here. Now what will be the nomenclature in this case? Obviously you have to start with the saturated atom. So this is first, saturated atom is the second, and then it's third, then it's fourth, then it's fifth, then it's sixth and 7. So the naming is very easy, because the saturated atom has started from 2. You have to follow this route rather than this route, because remember that the priority has to be given to the saturated atom. So the answer will be 1-ethyl 5-methyl 2, 3, 4, 5 tetrahydroazepine. Okay, so now we have completed our part 1 of the IUPAC nomenclature, of the Hans-Widman nomenclature and nomenclature of heterocyclic atom. Now in our next part 2, we will study the molecule having rings more than one heteroatom. Till then, thank you.